Welcome to Your Future, Your Way, where we explore the many ways to reach your academic and professional goals. Whether you are a recent grad, considering career advancement, or even changing careers, this podcast is for you. My name is Alyssa Olick, Director of Professional Degrees and Certificates, which is part of the professional programs at the University of Wisconsin-Madison. The professional programs portfolio includes 80-plus professional master's degree and certificate programs, as well as over 100 non-credit offerings that cover a range of topics from business to healthcare to education. We are excited to share information, resources, and most importantly, stories from current and former students.
Before we start, we want you to know that the views, information, or opinions expressed in this podcast do not reflect the views of the Division of Continuing Studies, the University of Wisconsin-Madison, or the Board of Regents.
UW-Madison's College of Engineering has one of the top-ranked graduate programs among U.S. public universities, including one of the top online master's programs. The college is also known for its diverse areas of study, as well as the variety of formats available for students to choose from. In this episode of Your Future, Your Way, we'll explore engineering professional programs. Accelerated programs, or fast-paced programs with higher course loads, allow students to be on campus and finish their courses in a shorter completion time than traditional master's programs. Accelerated engineering master's programs range in topics from automotive engineering to electrical and computer engineering, giving students the flexibility to learn the skills necessary to advance their careers. Meanwhile, interdisciplinary professional programs within the College of Engineering give students the opportunity to complete a master's degree or capstone certificate 100% online. Programs range in topics from engineering management and polymer engineering to sustainable systems engineering. Today, we will hear from a faculty member and a master's student within the Electrical and Computer Engineering Professional Program, a master's degree offering on-campus, in-person courses at a faster pace. Our first guest, Professor Barry Van Veen, has over 30 years of experience and works in the departments of Electrical and Computer Engineering and Biomedical Engineering. He starts by telling us how he decided to pursue a career in electrical and computer engineering and how it steered his research.
Why did I choose electrical and computer engineering? And the earliest thing I can remember was my grandfather, who was supervised a maintenance crew in a paper mill, talking about how those electrical engineers got paid so well. And that sounds like a really shallow, reason to make a decision, but I must have been 12 or 13 or something, and it made an impression. And I'm a first generation college student. My parents didn't go to college, my grandparents didn't, and that kind of thing. So, we didn't really know. I didn't really have the advantage of knowing what it was like to go to college or having someone direct me, right? So that made an impression, and I was good at math and science in high school, and so it seemed like a good choice to choose electrical engineering. So when I was an undergraduate at Michigan Tech, I got involved in a research project with a faculty member. And that was really what got me interested in graduate school, and even the area that I later went on to study, which back then we called it signal processing. Today, it overlaps. The hot terms today are more machine learning, artificial intelligence, data science, that kind of stuff. But so that project as an undergraduate got me interested. And in graduate school, and the faculty member I was working with really encouraged me to do that. So off I went. And somewhere in there, I went to graduate school thinking I was going to end up in industry. And by the time I was finishing my PhD, I was like, I want to be a professor. And so, here I am 30 plus years later, having been a professor all this time. Yeah, so my research area has when I was trained in grad school, we called it signal processing. And interestingly, today, the vogue term for that is more machine learning. But basically, electrical engineers have been building devices to sense the environment for, over 100 years probably, right? We've been building electrical devices to sense the environment. And so go back to radar in World War II, the measuring electrical activity from the brain. I think that was in the 30s. Anyway, so you make these measurements, then you want to say, well, what does it tell me? What can I learn from that? And that's really sort of a data science question, or, we're using computers to do that. So it's a machine learning question. Or in electrical engineering, we call these, when we sense the environment, we call those things, what we collect, we call those signals. So signal processing is a term that we use. What I really liked about that, so first of all, I got exposed to it as an undergraduate in this research project that I got involved in. And I found the blend between mathematics and physics and being able to pull information out of data. I found that really fascinating, how we sort of had these mathematical ways of manipulating data, and you could actually think about it in a rigorous and structured way to achieve some goal of extracting this information from data. So that really appealed to me, and that led me, to study that in grad school. And one of the things I've done pretty much, I started in grad school working on problems where you have data collected at multiple sensors. And how do you, use those measurements from multiple points in space to get additional information? And that has driven much of my career.
Next, Professor Van Veen discusses the accelerated and online master's offerings from the Department of Electrical and Computer Engineering and how the programs lead students to a wide variety of job opportunities.
We have different types of degree programs, and they're really designed to benefit different audiences or different types of students. So in electrical engineering, we have 4 different master's degree programs. We have a conventional, what I'll call 2-year research-based program, which is, you do a thesis or a project, and it's sort of, it's the natural thing people would do on their way to a PhD. And we have 2 programs that we call accelerated, and that's sort of a buzzword here at UW, but what that means is they're designed to be full-time residential, and you should finish in 3 semesters, okay, and a summer perhaps. So that's the target, 3 semesters or less. And then we also have in power engineering, electric power systems and power engineering, we have a master's degree program that is in that special topic, which is taught for an online audience. And so in electrical engineering, we have those 3 programs, and there are also similar breakdowns in other departments in the College of Engineering. The online program was intended for working engineers, and the typical student in those programs would have, they take 1, maybe 2 classes a semester. And so it might take them 3+ years to get through. And I've interacted with some of these students, and, I admire their commitment, their perseverance, because they're working a full-time job. They're taking this class in the evening. They've got, kids and family and stuff to manage. It's really pretty impressive that they are that dedicated. Now, the accelerated programs are course only. They don't require a research project or something like that. Okay, so there's 30 credits. All of our master's degree programs are 30 credits, but that you can't work full time and do one of these accelerated programs, right? So and typically the accelerated programs also are not funded in the sense that students don't get paid to teach or to do research and get their tuition covered like they would in a research-based program. We do in electrical engineering, we have offered some scholarships to help offset some of the costs, but in order to, finish in that time frame, you've just got, you really can't be distracted by work. You've got to focus all your energy on your coursework. And so what kind of jobs does this prepare you for? Well, if you ask, what role does electrical engineering play in society today? It's so pervasive and so fundamental that our world runs on electricity, right? Everything runs on electricity. We have all these great software devices now, but there's electronics that has to run that software. The computer has electronics in it and sensors, and go to the hospital, go get an exam, healthcare. And then, of course, we're trying to do sustainable energy, and everybody as well these days with the current price of gasoline, we're all sensitized to electric vehicles. And actually, the entire transportation system is undergoing a revolution in terms of becoming electrified, okay? Electric motors, believe this or not, battery-driven airplanes, from that to, to ships and so on, the whole transportation industry is going to be electrified. So, those create enormous opportunities for electrical engineers. Electrical and computer engineering as a field is so diverse that students really can go anywhere.
We will return after this short break.
This episode of Your Future, Your Way comes from UW-Madison Professional Programs, offering more than 80 graduate-level programs, including online, evening, and weekend options for working adults. For more details, visit us at go.wisc.edu/pro.
Now we will hear from Alicia Handa, a student in the Electrical and Computer Engineering Professional Program. Alicia shares details about her experience in the program, specifically why she decided to enroll in an accelerated professional engineering program at UW-Madison.
So my name is Alicia. I'm from India, specifically the north part of India, and from a city called Chandigarh. And I did my undergraduate studies in the field of electronics and communication. And so what really interested me about electronics was that it was so tangible and it was kind of ubiquitous, present in all in every technology that we have around us. I wanted to be a part of that. I wanted to explore that further. So I was in my pre-final year of my engineering, and I wanted to have more impact on the things that I did. For example, I did not want to restrict myself to a prototyping board. I wanted to go ahead. I wanted to sort of scale up and say, impact the performance of a processor. Or I wanted to try and save power on, let's say, an automobile that is using up a lot of power. And to do that, you do require a step up in your expertise, and you do require experiences that scale you up to the level where you can sort of impact in that manner. And so I thought, or I believed that the logical next step should be a master's degree to sort of accelerate myself or catapult myself in that direction. I decided to pursue my master's. I was very interested in the VLSI domain, wanted to touch upon the computer architecture domain, for which UW-Madison is very famous. So I started last fall. I will be graduating this fall. 3 semesters, that is, 4 if you count the summer. I am interning this summer with Texas Instruments, and you get credits for internship. So I would count, maybe we can count this as a semester. Roughly 16 months of your master's. And so if you balance your courses well, if you take, say, a very heavy project-centric course with, say, a lighter course that may or may not require a project, or which is okay or gives a literature survey the same amount of importance. And if you balance it correctly, or to your convenience, I think it is pretty much at a comfortable pace. Along with pursuing my courses, I was able to work part-time in my first semester in the Wisconsin Union as a caterer, and I was also able to perform in Shannon Hall. So we have an organization called the IGSA in UW-Madison, which is for Indian graduate students, and they organize these events on Diwali or sometimes Holi. And so I was able to perform there as well. So you can find time for your hobbies or something that interests you. So after I graduate, I hope to work for a product-based semiconductor or a semiconductor product-based company, mainly in the VLSI domain, maybe as an RTL designer, maybe as a verification engineer, maybe as a design for test engineer. There are a lot of options for people interested in VLSI out there. So I would like to sort of be a part of those opportunities. I would say if your end goal is getting into the industry as soon as possible, do seriously consider the accelerated program, because there are a lot of courses that hone or introduce you to skills that are pretty much required in the industry. I still remember I was interviewing with the company, and the interviewer said that, UW-Madison is a place where we keep hiring from, because we have people from there and we love people from there, and we would like to have more people from there. So the skills that this program would give you would be very much relevant to what you should have before you enter the industry.
Congratulations, Alicia, on your upcoming graduation from the Electrical and Computer Engineering Professional Program this December. Thanks for tuning in to learn more about the College of Engineering's professional programs. If you would like to learn more, go to pdc.wisc.edu/engineering to explore UW-Madison's online and accelerated engineering programs. Join us next time to learn more about professional programs at the University of Wisconsin-Madison. Learn how to shape your future your way.